Hello everyone, welcome back to Easy Knowledge. Today we will be continuing with our topic of the CIE Math Checkpoint Lower Secondary Examination Revision. This is part 2 of the previous video in which we will be covering algebra topics which I will tell you about in a moment. The topics we will be learning about today are topics 3 to 5, which are total surface area, subject changing, and inverse functions. So let's get started for today. Moving on to our third topic, total surface area or the TSA. Now, what is the total surface area of a prism? As we all know, all prisms have a net. The total surface area is calculating the area of the net. For example, in a cube, the total surface area will be the area of this net right here. The formula to calculating the total surface area is 6 multiplied by length square. Now, as we know, length square gives us the area of a square, and we'll be multiplying the area by 6 because a cube has 6 squares. In short, you can remember this formula as 6L square. Moving on to the total surface area of a cuboid, the formula is 2 multiplied by length multiplied by width plus width multiplied by height plus length multiplied by the height. So firstly, length into width will give us the area of the top and the bottom rectangles which have the same area. Then width into height gives us the area of these side rectangles which have the same area, and length multiplied by height gives us the area of the front and back rectangles which have the same area. So we will add up the area of all of these rectangles and then multiply it by 2 to give us 6 faces. In short, you can remember this formula as 2LW plus WH plus LH. To find out the total surface area of a cylinder, the formula is 2 multiplied by pi multiplied by the radius multiplied by the radius plus height. Now the full formula is 2 pi r square, since there are two circles in a cylinder here and here, and then 2 pi rh, which will give us this area. So when we factorize this, we get the formula 2 pi r plus h, which is shorter and easier to remember. Now, to calculate the curved surface area of a cylinder, which is this part, the formula is 2 pi rh. 2 multiplied by pi multiplied by the radius multiplied by the height. Now we will be finding out the total surface area of these three prisms. We will be adding the area of each side to get the total surface area. Firstly, we will be finding out the total surface area of the trapezoidal prism. So here, this measurement is 12 centimeters, as you can see. Now what we will be doing is, we will be multiplying the area by 2. So we will be doing 2 multiplied by half multiplied by 6 plus 12 into 4. So this will give us the area of both the trapeziums. We will add the answer by 10 into 12, which is 120. Then to find out the area of the top rectangle, we will be multiplying 6 and 10 together. So we will be multiplying the total which we have right now by 60, and then to give us the area of these two parallelograms on the sides, we will be multiplying 10 into 5 and we will be multiplying the answer by 2. So I have the calculation written out here. So this part will give us the area of both our trapeziums. Then after that, this will give us the area of the parallelograms. This gives us the area of a base rectangle, and this gives us the area of a top rectangle. So now we have the answer as 352 centimeters square. Now since we are finding the area, the unit will be square. This is very important to remember. So moving on now, in the triangular prism, Here both of these triangles have the same area and the same measurements. So the formula to calculating the area of the triangle is half into base into height, meaning we'll be doing half multiplied by 5 multiplied by 12. So here we will be finding out the answer of this, and then we will be adding it by 13 into 4. Then we will be adding it by 5 into 4, and then lastly we will be adding it by 12 into 4. Here I have the calculation written. So this part gives us the area of both of our triangles. Then this gives us the area of this top rectangle. Then 4 into 12 gives us the area of the base triangle. And then this side triangle's area is 5 into 4. So the total of it is 180-inch square. Now moving on to this compound shape. Here we will be cutting it like this so that we can calculate the area of both of these rectangles very easily. So here this shape is the exact same in the back, meaning both of these rectangles have exact duplicates. So hence we will be multiplying 4 into 3, and we will be multiplying the total by 2 to get the answer of this rectangle on both the sides. Then after that we will be multiplying 2 into 3 because the top area is 3 and we have cut it like this. 6 minus 3 gives us the area of this rectangle, which is 2 into 3. So the answer would be 6 centimeters square for this rectangle on both the sides. So we will be multiplying this also by 2. Then I will be showing you the calculation now because this one is a little lengthy. So as you can see, this gives us the area of this rectangle as I already told you. Then to finding out this area, we have formula 2 multiplied by 2 into 3. Then we will add it by 4 into 4 to get us the area of this square. After that, we will be finding out the area of 2 into 4 into 3, which gives us the area of this shape. Then after that we have to find out the area of 2 into 6 to give us the area of the base triangle. And lastly we have 2 into 4 to give us the area of this part. So now we will be adding it all together to get 144 centimeters square as our answer. I hope this concept is very clear to all of you since this is very important for your examinations and grade 9. Moving on to the fourth topic, subject changing. Now what is the subject of an equation? If the equation is x is equal to 2y, so here x is the subject. Now if we have to change the subject to y, what we will do is we will have to isolate y to the left side of the equation. So what will happen here is we will have to separate 2 from y. So as we know, 2 multiplied by y is what gives us 2y. So here is when we use the inverse operations. We will use the inverse operation to multiplication, which as you can see right here is division. So we will be dividing it by 2 on both the sides, since what we do to one side of the equation we have to do to the other. So here I have divided both the sides by 2. Now this 2 and this 2 cancel each other out, leaving just y, and here it becomes x upon 2. So x upon 2 is equal to y. This is how we use inverse operations and change the subject. Now preferably you would like to put the variable which you have isolated on the left side of the equation. So here we will write it in this manner: y is equal to x upon 2. I have an example here for more practice. 3x minus p is equal to 5y plus 7. Here we will have to make x our subject. So we will have to move p and 3 from here. So firstly we will move minus p away to the other side of the equation. So as we know, this is subtraction right here. So the inverse operation would be addition. So we will change this to plus p, and on this side also it will be plus p. So here I have it written right here. So 3x is equal to 5y plus 7 plus p. Now we will have to isolate x by dividing it by 3. So we will do divided by 3 and divided by 3, which here gives us x is equal to 5y plus 7 plus p. So this entire thing divided by 3. So this is how we change the subject. Now you can solve as many papers as you like on this topic, because the more you are familiar with changing the subject, the easier solving equations and most part of algebra becomes for you. Moving on to the fifth topic for today, inverse functions. An inverse function is an opposite of an order, which is a function given to a certain device. For example, if the function is x equals to minus 3, the inverse function of that would be the opposite of minus 3, which is plus 3 or simply 3. Hence, the inverse function would be written as x is equal to 3. Now, how would you write this? A function will be written as f into bracket x is equal to, and then the function, the order which is given. Now an inverse function is simply written with f raised to minus 1 into bracket x, and after that the order. Now where do we use inverse functions? We use inverse functions to solve equations. As we did to change the subject of an equation, we use opposite arithmetic operations to solve this. Now inverse functions are also used to reflect lines on a graph. We can also use a function to plot a line on a graph. Now that we know what inverse functions are, we are now going to find out 4 simple steps to finding out the inverse function. Our example is 5x minus 9. So I will be writing the inverse operations right here: addition, subtraction, multiplication, and division. And I will be putting a line here. Now, the first step to finding out the inverse function is we will be writing y and we will be cancelling fx, which leaves us with y is equal to 5x minus 9. Now after this we are going to be exchanging the places of x and y, which leaves us with x is equal to 5y minus 9. Now we are going to be making y the subject, meaning that the minus 9 will go to the other side. The inverse operation of subtraction being addition, we will get x is equal to 5y minus 9. Now minus 9 goes here to being plus 9, these two cancelling each other out, and now we have plus 9 here, which gives us x plus 9 is equal to 5y. Now we will be doing division by 5 to give us y isolated. So divided by 5 and divided by 5. Now here this 5 and this 5 gets cancelled, which leaves us with y is equal to x plus 9 minus 5 right here, as you can see. So this is how we find out the inverse function. And now lastly, we will be writing f raised to minus 1 x, and we will be cancelling out y, which leaves us with f raised to minus 1 into bracket x is equal to x plus 9 upon 5. So this is how you find the inverse functions. Now you can practice this. This is also a very easy topic. The more you practice, the better you know how to solve, and the quicker you can solve this. Thank you everybody for watching this video. Please like and subscribe to my channel. I'll see you all in my next video.